All right, so we are starting our triangle unit. And for this standard, we're going to talk about how to prove triangles congruent to each other. So triangles are congruent if all of the corresponding parts are congruent. So if you have two triangles and you know that there's 3 pairs of corresponding sides congruent and 3 pairs of corresponding angles congruent, then you know that the triangles are congruent. However, there are some shortcuts that prove triangles congruent without knowing that all pairs of sides and angles are congruent. And we're going to go through those 5 shortcuts right now. So for number 1, or one of the shortcuts is called the side congruence postulate. You are totally able to abbreviate side to SSS. So what this postulate states is that if I have one pair of sides congruent on my 2 triangles, another pair of sides congruent on my 2 triangles, and a third pair of sides congruent on my 2 triangles, I can now automatically say that these triangles are congruent without knowing that my pairs of angles are congruent to each other. Another way that you can show that 2 triangles are congruent is by the side angle side congruence postulate. A way to abbreviate the side angle side part would be SAS. So basically what this postulate states is that if I have one pair of sides congruent to each other on my pairs of triangles, and another pair of sides congruent to each other, and I have the angle in between these 2 sides congruent to each other. So what that means is that the angle touches both pairs of sides that are congruent. Then we do not need to know any other information about these 2 triangles. We can automatically say that these 2 triangles are congruent. All right, looking at the next one. I'm sorry, my numbering's off. On yours, it's fixed. So this is 3, 4, and 5. All right. So my next one, we have the angle side angle congruence postulate. A way to abbreviate angle side angle is ASA. And basically what this states is that if I have one pair of angles congruent on my 2 triangles, I have another pair of angles congruent on these 2 triangles, and I have the side that's in between these 2 angles, so the side touches both of the angles, then we can say automatically that these 2 triangles are congruent without knowing any other information about these 2 triangles. All right, so then the next one is the angle side, and this is a theorem, Congruence Theorem. A way to abbreviate this is AAS. Basically, this one states that if I have one pair of angles congruent and another pair of angles congruent, and I don't have the side that's in between the 2 angles, I have one of the other 2 sides. So I can either have this pair of sides congruent to each other, because it only touches one of the pairs of angles that are congruent, or if you had this pair of sides congruent to each other, that would also be AAS. Then we don't need to know any other information. These two triangles would be congruent. And then the last one, I have it fixed on yours, but these are right triangles. And so this theorem can only be used for right triangles. And it is called the HL Congruence Theorem. Which actually, sorry, let me write it out like I did the others. It's called the hypotenuse leg. Congruence theorem. So a way to abbreviate that is HL, congruence theorem. All right, so basically what this states is that if we have two pairs of right angles, and we have one, the hypotenuse is congruent, which the hypotenuses are always across from the right angle. And if we had one set of legs congruent, so if I have this leg congruent to this leg, then by the HL congruence theorem, these two triangles are congruent. Now, the reason why we have this theorem is because this is SSA, because these angles are congruent. And technically, one of the shortcuts that does not work is SSA. However, if you have a right triangle, SSA works, but we call it the HL congruence theorem instead of SSA. SSA will not work with any other triangle, pairs of triangles. And we're going to learn why in level 4. Another shortcut that does not work in proving triangles congruent is AAA. We cannot have 3 pairs of corresponding angles congruent and then conclude that our triangles are congruent. So I will learn why in level 4, but just know that these do not work. This one is a bad word backwards, and when it's a bad word backwards, you know that this is not going to work for you. All right, let's get started. So when stating triangles are congruent, we use something called a congruence statement. And when that's basically saying that triangle ABC is congruent to triangle DEF. When we are writing our congruence statement, the order of the vertices matters for the second triangle, so you want the corresponding vertices to match each other from both triangles. So for this new set of problems, it says decide if the two triangles are congruent. If no, we're going to draw an X through the blanks. If yes, we're going to write the congruence statement and state the postulate and theorem that shows that these two triangles are congruent. All right, so we are given some information for number 1. We have ZY congruent to YR. We have ZY perpendicular to TY. So that means that this is a right angle. And we have YR perpendicular to XR. So that's a right angle there. And we have TZ congruent to XY. So these two are actually right triangles, and we have the pairs of hypotenuses congruent and a pair of legs congruent. So these two triangles are congruent by HL. I don't need you to write congruence theorem, just give me the abbreviation. Now we need to state the congruence statement. So we need to put this in the correct order. So angle T on this triangle would be congruent to angle X on my other triangle, so those need to be in the same exact positioning. Angle Y on my first triangle is the right angle, so that's angle R on my second triangle. And so then angle Z and angle Y are congruent to each other, and those need to be in the same positioning. All right, the next one, we are given that AB is congruent to CD and BC is congruent to DA. And then these two triangles share a side in common. They both share side BD. So by the reflexive property, BD is congruent to itself. So these two triangles are congruent by side, side, side congruence postulate. Now, we need to pick out the congruent angles. Angle A on my first triangle is in between the side that I labeled with 2 tick marks and the side that I labeled with 1 tick mark. And angle C on my second triangle is in between those 2 sides as well. Angle B on my first triangle is in between the side that I have labeled with 1 tick mark and 3 tick marks. So angle D on my second triangle is the side that I have in between 1 tick mark and 3 tick marks. So that should go next. And then by process of elimination on my second triangle, we just have vertex B left. All right, next one. I am given TX congruent to BW, and TW bisects XV at U. So what that means is that XV is cut in half directly, so that XU and VU are congruent. And then we also can see that we have a pair of vertical angles. This angle here and this angle here are congruent. Now, for this one, this is side angles. So it's my swear word. And when we have the swear word, they're not congruent triangles. We cannot conclude that these are congruent triangles. So I just put X's through my blanks. They're not congruent. Number 4. So I have angle ADC congruent to angle ABC. And I have segment AC bisecting angle DAB. So angle DAB is this one here. So it cuts that angle in half. So this angle is congruent to this angle. Then these 2 triangles share side AC in common. So AC is congruent to itself by the reflexive property. So we have angle, side. That is one of our congruence statements. So these 2 triangles are congruent by angle, side. Triangle. On my first triangle, angle A is congruent to angle A on my second. Angle B on my first triangle is congruent to angle D, which then by process of elimination, angle C and angle C would be congruent to one another. Great. Number 5, we are given E is the midpoint of AB. So what that means is that AB is cut in half. And E is also the midpoint of DC. So that means DC is cut directly in half. We also have a pair of vertical angles that would be congruent. So these 2 triangles are congruent since the angle's in between my 2 sides. Then this is side, angle, side. Triangle AEC is congruent to triangle. So A is in between the side with no tick marks and 1 tick marks. And same with B on my second triangle. So those 2 are congruent. Angle E on my first triangle is congruent to angle E on my second. And then by process of elimination, we have angle D. All right, so we just have 4 more to go. On this one here, we are given some things in our figure already marked, but then we also have a pair of vertical angles. Since the side is in between my 2 pairs of corresponding angles, then this is ASA, which is a congruence postulate. So J is congruent to angle L on my second triangle. H would be congruent to angle C. And B is congruent to angle B. I need it to go in the correct order. All right, my next one, there's a couple of things marked, but also by the reflexive property, SH is congruent to itself. So this is angle, side, because that side's not in between my 2 angles. Angle S on my first triangle is congruent to angle S on my second. Angle D and angle R are congruent, which then by process of elimination, angle H is congruent to itself. All right, I'm going to have you try the next 2 by pausing the video. Okay, for number 8, by the alternate interior angles theorem, angle C and angle A are congruent, but this is SSA, bad word, not congruent. Here's your answer.